So, last session, we discussed about this introduction of Visual C#. Now, in this, yesterday's class, we covered all these points related with Visual C#. Okay, yesterday's class. And advantages of .NET over Java, that was another point we learned. Today, we are going to start with features of C#.NET. Now, in these features, first we learn about platform independent. And it's not pure platform independent, it's partially. Okay. Now we'll understand what it is through architecture. Instead of making theoretical points and getting confused, it's better I make one simple architecture to understand how what is platform independent. Okay. Now, whatever I cover in this topic, everything you come across even to study practically about it. Whatever we discuss in this topic, everything you come across at what? Practical of it. Fine. Let me just keep a heading for your reference as architecture of platform. Here I call architecture of platform independent. Okay. Now, right. Now, first part is, say for example, this is your .NET application. Okay, this one. So let me describe. .NET application. Okay. Where did you design this .NET application? So we'll take example of two languages. Either it is developed in C#.NET, or it is developed in VB.NET. Both are languages. Both of them are languages. C#.NET, VB.NET. And this program, when you write, you call it as source code. Program written by us. It's called source code. Okay. Now, interesting thing is, after developing a .NET application, we hand over this application to language compiler. To language compiler. So it is like this now. If your application is developed in C#.NET, you hand over it to C#.NET compiler. If application is developed in VB.NET, hand over it to VB.NET compiler. Similarly, if it is a program written in Java, give it to Java compiler. If it is a program written in C, C++, hand over to respective compilers. Same concept. Every language will have its own compiler. Okay. And interesting thing is, this compiler okay, this compiler. I said now, whichever compiler, in whichever language in which you develop the application. And what compiler will do? compiler will translate your code, and interesting thing is, compiler will generate one special file that you call as assembly. Our created file is source code. Our created file is source code. Compiler generated file is called assembly. What is that extension you'll have? Either you'll have .exe or you'll have .dll extension. Compiler generated file, that is assembly, will have any of these two extensions. Okay. exe executable, DLL dynamic link library. Dynamic link library. Okay, and one more thing. This compiler created file you call assembly asset, right? Assembly can be any one, I'm saying, either .exe or .dll. Remember, now we cannot learn about assembly in introduction classes in detail. Just I'll give you an overview. I said assembly, that's it. Assemblies are of three types actually. Assemblies are of three types. One we call private assembly. The other is called public assembly. Third one you call satellite assembly. Satellite assembly. Assemblies are of three types. That is the reason in my coming classes, under related to assemblies, we have one separate topic. So there, with practical, we will understand what is called private assembly, what is called public or shared assembly, and what is called satellite assembly. Okay, remember that point. Acha, the DLL I said now, DLL, dynamic link library file. DLLs also will be of three types. DLLs. One is called Win32 DLL. Win32 DLL. One more we have, they call as COM-DLL, COM-DLL, COM-DLL. And third one is called .NET DLL. Okay, so about all those DLLs in detail, about all the types of assemblies, we are going to study in detail with practical implementation in my coming classes. Okay, but at this stage, you just need to remember that whenever developer writes a program in either C#.NET or VB.NET, we hand over that program, your written source code, we hand over it to language compiler. And language compiler will generate assembly. And remember, what assembly contains, what it contains, remember, assembly contains special code in it, special code. And that code is called CIL code. CIL code. The two in binary format it will be. So general point I'll say, CIL code will be actually in two formats. Okay. CIL code text format will be there. CIL code binary format will be there. So now I'm talking about CIL code binary. What is CIL? Common Intermediate Language. CIL. Common Intermediate Language. CIL code. Okay. CIL code, Common Intermediate Language. Okay, and you know, in initial, when .NET was in its initial stage, the name was not actually referred as CIL code. This CIL code was actually called as MSIL code. Initial versions they used to call as what? MSIL code. And they had another name for it. Also, they called as byte code. Yes. MSIL code, and another name we have, and it is called byte code. MSIL, that is called Microsoft Intermediate Language. Later, they named it to what? CIL. Later. Okay. One more point also I'll highlight. One more point. What is it? This assembly, which is generated by compiler, it has another name as well. It has another name. That is, this file is also called PE file. One more name we have for it. PE file. That is called portable executable. Portable executable, PE file. Okay. And now remember, after generating this CIL code, now we hand over this code to various operating systems. Okay. So let's talk on that now. We hand over this CIL code to whom? Let me talk on two operating systems now. Two operating systems. This is one. This is one. This is one. Okay, let me talk on three operating systems. Right. What are they? Yes. First, we call Windows operating system. Yes. This is for Windows OS. And second is for Linux. Oh, sorry. Second is for what? Linux OS. And third one is for lightweight devices. That may be mobile, that may be tablet, that may be various other devices. So first I'll talk about Windows. Second, I talk about Linux. Third, I'll talk about lightweight devices. Yes, three. Put all of them here. Yes, first, Windows. Second, Linux. Third, lightweight devices. Three. And what are all these related to? OS. And now problem that you find is this CIL code, this CIL code, which you hand over to Windows, you hand over this to Linux, you try to make this work on, no operating system understands CIL code. Make clear on that point, please. Okay, shall I conclude with that point? No OS understands the CIL code. No operating system, no OS understands CIL code. Windows will not understand, Linux will not understand, right? Lightweight devices will not understand. The problem with CIL code, no OS understands. For that reason, Microsoft has made available one special component. one special component. And for every operating system, they give the special component. What is it? For Windows, they gave that component, that which you call as CLR. For Linux, they gave mono CLR. For lightweight devices, they gave compact CLR. Yes, this is now special software. CLR for Windows, mono CLR for Linux, and for lightweight devices, it is compact CLR. Three are there, three. What are they? Here I specify CLR. Common language runtime. That is what CLR stands for. Okay, and you know one speciality. First I said CLR, na? That works for Windows, and it works for Windows only. Mono CLR works for Linux only. Lightweight compact CLR works for lightweight devices. I cannot swap them. I can't use mono CLR for Windows, and I can't use CLR on Linux. And I can't use compact CLR in Windows and Linux. So always remember CLR is platform dependent, not independent. CLR is platform dependent. Why? Only CLR works for Windows. It works only for Windows. You can't use CLR for Linux. Mono CLR, they're designed to work for Linux. So it works for Linux only. Platform dependent, you call. Okay. And another point. Now the process goes like this. You give the CIL code to CLR. CLR will make Windows OS understand about it. Same CIL code you give to mono CLR. Mono CLR will take responsibility to make Linux understand about it. And same CIL code you give to compact CLR. Compact CLR will make understand lightweight devices. Right? And what is the understanding of this? What is the language which OS understands here? And here I describe all of them. I'll describe. And remember, OS understandable language is what you call native code. Native code. What do you call that as? Machine language. Native code. And what is this native code is all about? Machine language. OS understandable language. So who is making now OS understand? CLR. CLR will take that responsibility and make OS understand about that CIL code. Yeah. Now, question is, in this total process, where is platform independent story in this? Now I'll make that point highlight. And remember, in this total architecture, we find that CIL code makes .NET application platform independent. Yes. Which application? CIL code I'm saying. Because same CIL code we gave to Windows. Same CIL code we gave to Linux. Same CIL code we gave to lightweight devices. Same, I guess. Same. And everywhere you can see that CIL code was executed in all three operating systems. So who is platform independent here? CIL code makes your application platform independent. Okay, now something important connecting with CIL I'll mention here. CIL oblique MSIL code, which you also call bytecode. Now I'll make what CIL instructions are platform independent instructions. Second rule, CIL is an intermediate instruction set which is independent of processor and hardware. Third rule, CIL binary form is called PE file, portable executable. Portable executable, PE file. Okay, these are the important parts connecting with what? CIL or MSIL code. Yeah. So you have anything that you want to ask me on this? Go ahead. If not, I'll come up with my second architecture on this same concept. Features. First feature we are talking, platform independent. So already one architecture I covered. Architecture of platform independent. Refer to .png file. Yeah. Any question that you want to ask me on this? Everyone?
No.
No? Okay, fine.
I missed the starting, but I can watch it tonight.
Okay.
If any question, then I ask tomorrow.
No problem. You go through the video, you can get clarified. No issues.
Yeah.
Yeah. Lakshman, you have anything to ask on this? Chalapati Rao, what about you? Savitri and Saurabh Singh. If there is an issue at your end with your mic, then headset, then you can just use chat panel in the application and confirm it through chat panel. There is a chat panel in the application. Okay. Second architecture. Here I'll give you detailed description of what all happens at compilation now and execution as well, both. Architecture of code, compilation and execution. Everything I'll cover. I just said CLR. No? What internal happens in CLR, those things I'll highlight. And what internal happens in language compiler, those things also I'll highlight. Refer to .png file. Chalo, right. Come back, please. Open paintbrush again. This is about what now? Compilation and execution process in detail. When you start writing program, we correlate every architecture there. Every architecture when we start writing program. Probably it may take one or 2 days to start with practical. So whenever I start practical, I'll correlate and explain you what is happening in the concept of coding. And one more important thing, not all features we can study in introduction classes. Whatever features that you can study, those things I'll highlight. Some features are there you cannot study in introduction classes. Let me explain you one point. There is one new feature introduced in .NET by something called WPF. So you cannot understand about WPF in introduction classes. Or there is something called ADO.NET, also one feature. We cannot understand about ADO.NET everything in the introduction classes, right? We don't understand what is about multi-threading in introduction classes. So some features we just make a list for theory, just for theory, nothing else. We don't talk even about them at all. I just make them as theoretical point. That's it. Okay, chalo, right. Now I'll make detail architecture on this part. And whatever I'm going to make here now, everything practically we'll try to understand. Okay. Architecture of code, compilation and execution. This one. Architecture of code, compilation, execution. Yes. Now I'll make two blocks now. I'll make two blocks. This block is for the concept of compilation, to understand about compilation. And this is another block to understand about execution. Chalo, fine. I'll make two blocks as well. Right. So this is all about compilation. And this is all about execution. Okay. Now I'll say, now here, first we'll talk about source code, source code, your written code. Okay. Then I'll talk about C# compiler. That is what you referred, language compiler. And language compiler generates one file here, one file. That file we called assembly. Mention all of them first. C#.NET application that you call as source code. And file, what it creates is .cs extension, as refer as C# file. Source code .cs file. Hand over to whom now? Obviously, language compiler. Language compiler. Yes. And this language compiler generates. What is this file called? I already said, this file created by compiler you call by a name assembly. .exe or .dll, and you call this file as p file. What do you call this as? PE file, portable executable. Okay, all you mention here. Yes. And now important thing. And that important thing is, I'll just put the big arrow mark so that you could correlate easily. Yeah, like this. Now keep this. You keep this. Okay. Now remember, this assembly is there, no? Which is created by compiler. Remember, assembly contains, internal, it contains 4 components. Four components. What are they? I'll make a list now. This is one component. This is one component. This is one component. This is one component. 4 components will be there. 4 components. And you know, among these 4 components, every component will become compulsory for real time. Real time. Everything is important. That is the reason when we come up with practical, na, at that time, I'll explain you in detail about these all things. Chalo, right. Now give the names, please. Names. First component is called assembly manifest. First one. Second, CIL code in binary format. Third, you call metadata. Metadata. And third one is what you call resources. Yes, 3 things. Okay, highlight them now. First comes assembly manifest. Second is CIL code in binary. And then metadata. And then resources. Yes. Total how many? 4 components. 4. Now what would you do? This assembly you hand over for execution to whom? CLR. Okay, let me connect this then here. Yes. This assembly we hand over to whom? CLR. Yes. CLR. Yes, CLR. And you know, internal, what happens? Internal. I just, in that architecture of platform independent, just I use a word CLR. What is CLR and all I describe. But now we need to know what internal CLR does. CLR does. And remember, CLR will take this assembly. And it will hand over that assembly to one of its component. Yes. CLR will hand over that assembly to whom? One of its component. Yes. And what is that component? what is the actually, coming classes may we have quite a very detailed to study about this since that we are and
So the voice is not audible.
component. This is what you call. Is it so? Just 1 second. Let me check once. 1 second. 1 second. Your voice is breaking. Okay. Just give me a second. Just 1 second. Yeah. Hello. Am I audible now?
Yes.
Yes, sir.
Yes.
Okay, fine. Right. So, what did I say? CLR. We hand over this assembly to CLR. CLR will give that assembly to one of its, what I said, component. Okay. Component. Component. And remember, I just gave you point. CLR has, I'm not saying like one component. I said CLR has many components. Among those many components, I'm talking about one component now. So CLR has approximate, I'm saying approximate. CLR internal contains around 11 to 12 components. In that 11 to 12 component, this is one component. This is one component. Okay. What is this component? This is what you call JIT compiler. Internal of CLR, you have JIT compiler. That is what you call just-in-time compiler. JIT compiler. Just-in-time compiler. So, is it not that makes you easy to understand that now with this architecture that you got two compilers now? Two compilers. One is language compiler that will generate assembly. Internal of CLR, there is one compiler named JIT compiler. JIT compiler, and that JIT compiler is what you call just-in-time compiler. And make another interesting thing here, as far as .NET is concerned, we are made available 3 types of JIT compilers actually. 3 types. Then what is that we are talking about? You said only JIT compiler. So what is this compiler then? This is normal JIT compiler. We have another compiler, right? That we call as pre-JIT compiler, pre-JIT compiler. We have one more called econo-JIT compiler. Total 3 types of JIT compilers will be there. Every JIT compiler has got its own unique significance. Okay. So what this JIT compiler will do? I'll describe here. JIT compiler. What it does? Translates required code in execution. Translates what? Required code in execution. What is the meaning? Means usually when you write a program may have thousands of lines of code in it. What JIT compiler do? JIT compiler will not translate all 1000 lines. JIT compiler will translate what is needed in runtime, what is needed in execution, only that part it will translate, which is not needed, it will ignore. I'll give you an idea now. I'll give you an idea. You know about everyone, like, a basic point of programming. There is, in programming, we have something called if condition. If condition will have two blocks. True block, else false block. And you all know very well that if condition never execute true and false both. If condition, when we write, never, I'm saying never it execute true block, false block, both. It execute either true or false. If it is executing true, confirm. False is not false, it won't execute. If it is executing false, it means true block will not be executed. Any one will run. Never two are executed. That's what I mean. If condition is true, JIT compiler translates true block, ignores false. If condition is false, JIT compiler translates false block, ignores true block. Any one. That's what the meaning. Required code in execution. Okay. What it is generated? Yeah, I'll mention here. JIT compiler translates required code in execution to what? To native code. Native code. That is what you call as machine language. And that is being generated for operating system. Yes. Native code. OS understandable code is called native code. Technical word is machine language. And this is being generated for operating system. And what other work JIT compiler will do, what JIT compiler will do is, after generating this native code, JIT compiler, what it will do is, it will create that native code stored in buffer, or you call cache memory. Stored into buffer or cache memory. Yes. Why it will store? So that you can have reusability. For reusability. Yes. To have reusability of the code. To have reusability of the code. JIT compiler generates required code in execution to native code, and that native code is stored into what? Buffer or cache memory. Yeah. Any questions that you want to ask me on this, or shall I continue with the next part? Yeah. Any queries? Hello? Am I audible to everyone? Hello?
Yes, sir.
Was it clear?
Audible.
Like,
Yeah, we are following you.
okay, fine. Okay, right. Okay, Saurabh Singh, fine. Savitri, are you there?
Sir, I'm there.
And is this clear for you, both the architectures?
Yes, sir, both.
Okay,
Clear.
fine then, fine. Okay, okay. Right. For your instant reference, let me just make a list for you here about the types of JIT compilers. Types of JIT compilers. One, what did I say? Normal JIT compiler. What it will do? This compiler, just know the demonstration what I give, related to that I'm talking, will compile required CIL code at execution to native code. And the code is stored in buffer or cache memory. Second rule, the converted native code further can be reused. Yes, that is about normal JIT compiler. Second, we have pre-JIT. Pre-JIT. This compiler will compile complete CIL code to native code. Then third, we have interesting thing. Previous point was required CIL. In pre-JIT, complete CIL. Not required. Total, true, false. Both blocks, it will translate to native code. And third one is called EconoJIT compiler. This compiler will compile required CIL code at execution to native code. But the code will not be buffered like normal JIT compiler. Buffered or cached for reusability. Yes. That is the story of what? Types of JIT compilers. Okay. Chalo, finally, with one more architecture, we'll complete our first feature of C#.NET. What is it? This is what you call reverse engineering in .NET. What do you call that? Reverse. And remember that, please, in the previous architecture, which I have explained you in the code compilation execution process, let me be clear on this. I haven't explained you any component that which is a part of assembly. I didn't explain you what is assembly manifest. I didn't explain you about CIL code. I didn't explain you much about metadata. I didn't explain you anything about resources. These all things you will get to know quite in detail. As I said you in my coming classes, we got to have a separate topic called assemblies. In that topic, you will get to know detail everything. I'll elaborate on the day whenever I take up the topic of assemblies. Okay. So introduction classes, even if I explain you, things may not be that clear to understand about those 4 points.
Sir, again, your
So
voice
you
is
have
breaking.
to wait for few classes. So whenever there is a message actually flashing even on my screen, like your internet connection is something like not stable. Some message is coming. Okay, then we'll do one thing, like some issues are there. So instead of continuing, I'll just stop the session here. Tomorrow's class, I'll continue with the topic called reverse engineering, about reverse engineering.
Okay, sir.
Okay, and that would be best, I feel. That would be my third architecture, actually. Architecture of compiler and assembler, and what you refer as reverse engineering. in .NET. Yeah. And this also will have to .png file. Tomorrow's class, I'll take up this because however there's some disturbances there in the network. So better tomorrow's class, I'll continue with this. And we'll continue with remaining features also. 2 more features, I can go in this detailed way of explanation, and remaining features, I just write theory. Explanation will start whenever that particular topic comes for us. Okay, everyone? Is it clear for everyone?
Okay, okay.
Okay. Right. Bye, everyone. Bye. See you all tomorrow. Bye.